Hello everyone, my name is Galsar. I am going to discuss about the well test analysis in lean gas condensate reservoir, which is the part of my assignment which given by Dr. Pawan Gupta sir.
Let's begin with the presentation. Well test analysis in lean gas condensate reservoir. Outline of my presentation. Introduction, condensate saturation profile with condensate dropout and velocity stripping. Impact of capillary number effects on saturation profile. And summary of result and conclusion. Beginning with the introduction. Gas condensate reservoir exhibit a complex behavior when the well are produced below the dew point due to extensions of the two fluid system, reservoir gas and liquid condensate. Gas condensate reservoir are becoming more common as deeper depths are beginning targeted in the exploration of oil and gas. The behavior of such a system are complex and still not fully understood, especially in the near wellbore region. Different mobility zones develop around the wellbore corresponding respectively to the original gas in place. The condensate dropout and capillary number effect, which is close to the well. Condensate dropout cause a non-reversible reduction in well productivity, which is compensated in part of the capillary number of effect. All this effect can be identified and quantified from well test data. The test is condensate reservoir, however, they tend to be difficult to interpret. Build-up and drawdown tests are usually dominated by the wellbore phase redistribution effect, and main analysis challenge is to the distinguish between reservoir effect and boundary effect, the fluid behavior and wellbore phase redistribution perturbation. Condensate saturation profile with condensate dropout and velocity stripping. So what is the condensate dropout? The saturation of condensate gas will increase in the near wellbore region. And what do you mean by velocity stripping? The velocity stripping, that means the increase in the gas mobility in the immediate vicinity of the wellbore. The characteristic of the gas condensate production in the creation of the condensate bank. When the bottom hole pressure drop below the dew point, the reduce in gas relative permeability around the wellbore and leads to loss of productivity, with some well even ceasing production completely due to condensate loading in the wellbore region. This is called condensate banking effect. Already we discussed that the velocity stripping means the increase in the gas mobility in the immediate vicinity of the wellbore. What are the impact of the capillary number in saturation profile of the gas condensate? So what is a capillary number? The capillary number is dimensionless parameter that represent the ratio of the viscosity to capillary force. As we see the formula of the capillary number. Here the V is represent the velocity, mu is the viscosity, and sigma is the interfacial tension. The high capillary numbers are obtained for the high flow rate or low interfacial tension. Capillary number effect create the three region composite well test behavior with three derivative stabilizer. As we see in figure, the gas effective permeability decrease in two phase region as oil permeability is increased. This graph is condensate saturation versus radial distance from the well. From the below graph, we can see that this permeability of the gas is reduced faster in the vicinity or the velocity stripping zone than elsewhere in the reservoir. Hence, the first stabilization line is disappear when the near wellbore gas effective permeability is become less than that in the mobile zone, in which case the two-phase radial composite behavior develop. Here we say as the time of the period will increase, the saturation of condensate will increase, and the radial distance is increased, where the saturation of condensate will be decreased. After some time, the saturation is increased away from the wellbore. From this graph, the condensate saturation versus radial distance. Here we can see that there are main two phases. One is the pressure which below the dew point. One is a pressure which is greater than the dew point. Here the four sub-region develop near the wellbore with different liquid saturation. First is away from the wellbore where the dew point pressure is greater than the reservoir pressure. And the second phase, the condensate bank region, velocity stripping zone, mobile oil zone, which is the which pressure is less than the dew point, where the two phase are beginning. Here we can see that the start of the two phase will increase the saturation of gas condense will increase the saturation of condensate as the pressure reduce below the dew point. The region 4 that contained with gas initial liquid saturation. Here we can see that the original saturation of gas will decrease as increase of the pressure. There is an intermediate region with a rapid increase in the liquid saturation, a corresponding the decrease in relative permeability of the liquid in the region of immobile. Here the permeability of the liquid will be decreased because the oil is immobile. Near wellbore, where the liquid saturation reaches the critical value. Here we can see that the saturation of the liquid will reach the critical saturation of the oil. The effluent travel as the two-phase fluid with the constant composition. In detail, we can say that the condensate deposit as pressure decrease and equal to that flow of the towards the well. This graph is the non-normalized single phase pseudo pressure versus the elapsed time. As the saturation of gas will increase and decrease, the fluctuation of the graph we can see that. From the line A, we can see this gas with lower condensate saturation with the capillary number is low compared to the gas with initial condensate saturation. Line B, we can see that the high condensate saturation and liquid drop rate. That means the sum of the part of the liquid will start to beginning, and the two phase behavior can see that. This comparison is schematic pressure and derivative composite behavior, three-phase region and two-phase region. This is already discussed in previous slide. From the all presentation, these what are the result obtained from the well test data? The condensate deposit around the well when the bottom hole pressure drop below the dew point during the production. The reservoir effective permeability is consistent with the core permeability in the sandstone reservoir. The core permeability can be used to distinguish between condensate bank and the reservoir mobility if only a single stabilization is seen on the derivative. The condensate bank decrease in size and saturation when the production rate decrease. The behavior often changes with the time as the condensate bank grow and reach to the boundary. A successive drawdown and buildup must be analyzed together to understand these changes. Here we conclude that an interpretation methodology is described which use time-lapse analysis, deconvolution and different analytical and numerical tools to identify the probable cause of the pressure data behavior, two-phase region and three-phase region analytical composite model to represent the various mobility zones around the wellbore. These are my reference. Thank you.